Hello everybody, today starts our exploration of real-world systems of equations, and we're going to get right into this whitewater rafting scenario. Let's read it together. It says, Chase is an experienced guide who takes groups of adults and children out on the water for amazing adventures. The super raft he uses can hold 800 pounds of weight. Any weight greater than 800 pounds will cause the raft to hit more rocks, maneuver more slowly, or potentially sink. Chase estimates the weight of each adult as approximately 200 pounds and weight of each child under age 16 as approximately 100 pounds. Chase charges adults $75 and children under age 16 $50 to ride down the river with him. His goal is to earn at least $150 each rafting trip. Now that's definitely a lot of information, and we're going to use our reading skills to kind of break this down a little bit. First, I'm asked to define variables. So from all of our class practice, I know that I'm going to have x and I'm going to have y. I may not be sure yet about what my variables are, so I'm going to go back and look and see what's measurable, or what are the two things that are being discussed. I see information about weight, and I see information about money. We're talking about two different adults. We're talking about two different people, adults and children. So x is going to be, I'm just going to let x be number of adults, and I'll let y be number of children. We're going to have one equation that's about weight and one equation that's about money. Number 2 says, write an inequality to represent the most weight Chase can carry in terms of rafters. So let's go back and reread, and I'm going to give you a second to read and find that information about weight. And this should sound to us like an ax plus by equals c equation. I don't have a starting weight, so to speak, and then add weight per person. I know something about grown-ups, and I know something about kids. Go find it. So as you scanned through, I'm hoping your attention was drawn to this sentence right here, that Chase estimates the weight of each adult is approximately 200 pounds. So 200x, and then the weight of each child is 100 pounds, plus 100 pounds times y, because we don't know how many kids are going yet. And let's see, this raft can't have an infinite amount of weight on it. So can you please read again and see what's the constraint, what's the limit on the weight that can be in this raft? Again, I'm hoping our attention was drawn right here, where it says that the raft can hold 800 pounds. So your decision, I don't have anything like up to or more than to help me, so let's reason on this. If the raft can hold 800 pounds, would that be less than or equal to 800 or greater than or equal to 800? In the real world, this is going to be less than or equal to 800. It can't hold more than that. So our first inequality is all set. The next one we're asked to write, it says write an inequality to represent the least amount of money Chase wants to collect for each rafting trip. And it makes sense that he'd have a minimum amount, right? Because he has people to pay, right? There's your guide. The raft itself and the paddles and the helmets, all of that has an equipment cost associated with it. So he needs to make a certain amount on each of these trips. So now, this one was all about the weight. This one was weight. This one's going to be about money. So please go reread, and on your own, we're looking to build another ax plus by equals c inequality using the information about the money. So go find that. So rereading for information about money, my hope is that your attention was drawn right here. Chase charges adults $75, so that will be 75x, because x represents adults. And children under the age of 16 are $50, so there's a discount for them. So plus 50y. His goal is to earn at least $150. So he wants to make at least that, so greater than or equal to 150. And if you weren't sure about the inequality sign, you can kind of change it. Like let's say at least 5 people need to go. So that means 5 or 6 or 7 or 8 more, right? At least 150 bucks in your pocket. That means you have 150 or 151, 152. So that's a way to reason out that this means at least means greater than or equal to. We now have our two inequalities. So notice in question 4 it says write a system of linear inequalities to represent the maximum weight of the raft and the minimum amount of money he wants to earn. So we're going to take each of these equations and write them together. So this is going to be 200x plus 100y less than or equal to 800. And again, this one was about the weight. And then 75x plus 50y greater than or equal to 150. That was about the money. Together, these two inequalities make up the system. From here, let's see what follow-up questions were asked. It says, consider the past 2 trips that Chase guides. Determine whether each combination of people is a solution of the system of linear inequalities. Then describe the meaning of the solution in terms of this problem situation. It says here in A, the first trip, that Chase guides 2 adults and 2 children. So how am I going to determine whether or not this combo of people works or doesn't work? Well, my first thought is that adults is X and children is Y. So as an ordered pair, what would this be? 2 adults, 2 children? I'm looking to check two. So let's check. In class we talked about how to check an ordered pair. We're going to be plugging it in for X and for Y. So using this as a guide, I'll use this first equation. So it's going to be 200 times 2 plus 100 times 2 less than or equal to 800. Let's see if this comes out true or false. Well, 200 times 2 is 400. 100 times 2 is 200. Less than or equal to 800. 400 plus 200, 600. Is 600 less than or equal to 800? Yes. So this means the weight is all good. You're not going to exceed your weight. Because this equation, or excuse me, this inequality was all about staying underneath the 800-pound limit that you can have on the raft. But it has to satisfy both, because it has to work with the weight and the money. So now let's go check the money. 75 times 2 plus 50 times 2 greater than or equal to 150. Let's see, 75 times 2. If you need to get your calculator, pause to go get it. I'll wait. Or we just know. That 75 times 2 is 150. Think 6 quarters is $1.50. Plus 50 times 2, which is 100, greater than or equal to 150. 150 plus 100 is 250. Are we good? Let's see, is 250 greater than or equal to 150? Yes. So that means that his profit, because this was all about money, is good too. He needs to make at least 150 He'll make 250. If this is a family, for example, of 2 adults and 2 kids, he's good to go. So the answer is yes for this combo of people. 2 adults and 2 children, he's good to go. Now let's see this second trip. It says that Chase guides 5 adults. So once again, I'm looking for X and Y. Adults is X, but I don't see any value for Y. So no Y value means no kids. That means that we have 5 adults and how many kids? I'm hoping we say right now 0, and you would be right if you were thinking 0. No kids are going, just 5 adults. So we're going to check 5, 0. Please press pause and you check this point and see what we get. If you're listening from this point forward, it means that you did press pause and you've worked this out, so let's see if we match. 200 times 5 plus 100 times 0. I could start with the other one, I just choose to start with this one. So let's see, 200 times 5, that's 1,000, plus 100 times 0 is 0, less than or equal to 800. 1,000 plus 0 is 1,000. Let's see, is 1,000 less than or equal to 800? No, definitely not. So what does that mean? It means that if 5 adults go, that's an estimated weight of 1,000 pounds. That is more than this raft can handle. The raft can only handle up to 800. Too much weight. So this group of 5, at least in this size raft, is no good. Can't take them out on the trip. So now we have a great understanding of what it means to check real-world values, real-world ordered pairs, in a real-world system. Now let's see what the graph's going to look like. So number 6 says, rewrite your system from number 4 here and graph. So let's rewrite. It's going to be 200x plus 100y less than or equal to 800, and 75x plus 50y greater than or equal to 150. I literally just copied those from the front page. And maybe just to make these stand out, I'm going to put them in a box. So here's my system for number 6. To graph, imagine I had given this question to you in the skills section, and we should be pretty comfortable. Even though they look like crazy numbers, remember, once we're in a real-world situation, solving for y and graphing might be a little tricky for us, but if you are adamant about getting mx plus b and using the slope and intercept, by all means, go for it. Our graphs should match. I'm going to, for the purpose of the notes, I'm going to graph by intercepts because that's a surefire way to quickly get our graph, graphing by intercepts. So I'll take the first equation, I'll rewrite it, inequality. 200x plus 100y less than or equal to 800. I'm going to put x int, let y equal 0 to remind myself how to do that. So let's do this. X-intercept, let y be 0. So that's going to be 200x plus 100 times 0 equals 800. Remember, we're solving for an ordered pair, so if you choose to set that to an equal sign, that's cool. If you want to leave it as an inequality, that's okay too. So it'll be 200x less than or equal to 800 divided by 200 divided by 200. X is less than or equal to 4. So I get x equals 4, which means my ordered pair is 4, 0 for the x-intercept. Now let's find the y-intercept. To find the y-intercept, we let x be 0. So that'll be 200 times 0 plus 100 times y. If you choose to leave the inequality sign, that's fine. Less than or equal to 800. This is gone. And from here, we should be very comfortable at this point solving these. So I get y is less than or equal to 8. my ordered pair from this, or excuse me, we could also say y equals 8 for the sake of the ordered pair. X is 0, y is 8. That makes 0, 8. Let's plot. So 4, 0 is right here. 0, 8. Zero, 8 is here. I know that this is going to be a solid line. So I'm going to take my straight edge and I will sketch a solid line all the way through. We do need to check 0, 0 for shading. So I'm just going to draw a little arrow and say check 0, 0. This will be super quick because a lot will cancel, which is nice. So we have 200 times 0 plus 100 times 0 less than or equal to 800. Gone, gone. 0 less than or equal to 800. True. So that means we're going to shade the side that 0, 0 is on. Here's 0, 0. So I shade this way. Remember, just some nice straight lines like this that kind of match the angle of the line. It'll make it much easier for us to see the shaded region, and also make sure we don't have interference when we go to graph the second line. We're literally going to repeat the exact same process, but with the second equation. So it's going to be 75x plus 50y is greater than or equal to 150. I'm going to use the exact same subtitles. X int let y equal 0. And then y int let x equal 0. Please press pause. I'm actually going to pause the video as well. When you press play, all of the work will be here so we can check our answers. So please press pause, you calculate your x and y intercepts, and then we will compare. And I'm back with you. Here are my values for the x-intercept and the y-intercept. Do we match? For the x-intercept, I got 2, 0. For the y-intercept, I got 0, 3. Hopefully we do. If we don't, press pause, and let's compare our work. Those of us who are good to move forward, let's graph. So 2... Sorry for the bells, guys. 2, 0 will be right here. 0, 3 will be right here. And this is where we definitely want to use a straight edge because crooked lines here are going to mess us up. So I'm going to get my straight edge, so to speak, with my line. Get your straight edge, your ID, or take a piece of paper, fold it twice. It'll make a nice edge. This is what I get for my second line. And once again, we'll very quickly check for 0, 0. I'll put it over here. Check 0, 0. So that will be 75 times 0 plus 50 times 0 greater than or equal to 150. Cross out, because that's both 0 and 0. I get 0 greater than or equal to 150. False. So, for this second line, I want to shade the side that 0, 0 is not on. Here's 0, 0, so I go shade the other side. And I should have done a better job with the black lines here, so I'm going to adjust that real quick, because my next question to you is, where do the black lines and the purple lines overlap? Well, clearly I see here is just the black lines, and over here is just the purple. My intersection, if you have a highlighter, grab your highlighter. The intersection happens here. So this is my shaded region. But I'm actually going to back up my highlighter real quick because can you have, remember, the x-axis represents adult rafters. Can you have negative rafters, negative adults? Nope. And here the y-axis represents children. Can you have negative children? Again, no. So the real world answer is what's strictly in quadrant 1. This is quadrant 1. Any ordered pair in this shaded region, that's yellow, will be a real-world solution. So the math answer for the shaded region would be this entire middle part that I'd highlighted at first. But the real world, again, we can't have negative people, is just what's here. We'll pause there for today's flipped notes, and we'll start class tomorrow by working on number 7, analyzing the graph. If you have a couple minutes, by all means, please sketch your thoughts for number 7, A, B, C, and D. And it would be great for you to come with some ideas to share with everybody. Nice job, and I will see you tomorrow.